Hey guys, and welcome to Coding Simplified. So this first video is going to be about one of the most common concepts in computer science, and we're going to be implementing it in one of the most popular modern programming languages. Today we're going to learn about looping in Python. I also hope to go a little bit beyond the syntax of the language and get into some of the concepts about looping in general, but we don't want to go so deep that we get lost in all the details. Just as a starting note, I want to let you know that I'm writing all my code in a free tool by Google called Google Colab. So all you have to do is type this into any search engine, and you click enter, sign in with a Google email, and create a new notebook. It's as simple as that. So let's start talking about looping. So when we write code, we're giving the machine a series of instructions to follow, and these instructions are broken down into a language that the computer can understand, and then they're performed by the central processing unit, or the CPU. You can kind of think of the CPU as the brain of the computer. Now, the important thing to keep in mind when we're talking about looping is that the CPU can only do one thing at a time. Now, as a short disclaimer, there are techniques involving pipelining, multiprocessing, multiple CPU cores, things like that do allow computers to do more than one thing at the same time. And in fact, these are topics that we will likely cover in a later video. But for right now, just assume that the computer is a strict monotasker. It can only handle one thing at a time. Therefore, when you write a piece of code, it's like writing a recipe for the computer to read. And the computer uses this recipe to cook a meal, which is the software that you're running. So when the computer is reading the code, there's only really two things it can do. It can read the next line, or it can jump to another place in the code and hopefully return to where it left off at some point. So let me show you what I mean. So when we're trying to keep track of code, one of the simplest things we can do is write what's called a print statement. So if I write print, and then some parentheses, and then some quotations, whatever I put in here will get print out by the computer. So I can say, I am on step 1. Now I can copy and paste that to a few different spots. And then if I do, I am on step 2, I am on step 3, I'm on step 4. So what should happen when I press this little play button and run through this code, it should go line by line, straight down from top to bottom, reading this recipe. And what it's going to do is print out, not to like a printer, but it's going to print it out to the screen. Let me show you what I mean. So I press this, wait for it to run. Right now it's going through all the different steps. But there we go. I'm on step 1, I'm on step 2, I'm on step 3, I'm on step 4. So it's not jumping around. It's just going top to bottom in order. Okay, so where do loops come into this? Well, loops are just one of the simple examples of a case where the program doesn't just move on to the next line. So if the code is a recipe, a loop would be like repeating a step. So let's replace some of these with cooking things, okay? So crack eggs, beat the eggs, cook eggs, and then eat eggs, okay? So if I run that, it's the same thing as before, but now it has the different steps. So it's reading this recipe and it's executing these. So if a loop is like a code repeating a step, this brings up a question. How many times should the computer repeat a step? It could just keep going on forever, but most of the time this isn't what we want. And in fact, programmers spend a great deal of time trying to make sure that infinite loops don't happen in the code, because they can eat up a lot of resources and lead to crashes and all sorts of other problems. So what we need is some method to know when we can stop looping and stop repeating a step. In our recipe analogy, if our looped step was to keep adding water to a bowl, so imagine we do all these, and then we come down below to a new spot, and we say, add a cup of water. Well, what if we want to do this over and over? So with our recipe, we might choose to stop when the bowl is full, or maybe after we add 3 cups or something like that. So these things about the bowl being full or how many cups you're adding, these are called conditions. So the bowl is full is a condition. We added 3 cups is a condition. So a condition is something that can either be true or false. So for example, a bowl can either be full or not full, but it can't be both, and there's no other thing that it can be other than full or not full. So another thing we have in code are variables. And variables are just pieces of information that can change while the code is being executed. So for example, we could have a variable saying how many cups of water are in the bowl. If we know that the bowl can hold 6 cups of water, if our variable reaches 6, then our bowl would be full. So let me show you how to write a simple variable. All you have to do is have a name for the variable. It could be something like cups. And then you have an equal sign, which assigns a value to this cups. So we could start it off at 0. So there's no cups that we've added. Okay, so let's use this example of adding cups of water to a bowl to help us understand loops in Python. So we're going to start with a variable called cups, and we're going to assign it a value of 0. Okay, so if I said print cups, it'll print 0. But what I can do is add a cup. So I can say cups plus equals 1. So what this does is it says cups is equal to whatever it was before, which was 0, plus 1. So that's what the plus equals does. And this is also called incrementing. So you're incrementing cups by 1. So now if I print cups, it should be 1. There we go. Cups was 0, now it's 1. Okay, and we can just keep adding these by hand until we get to 6, but that would take up a whole lot of code. It'd be very repetitive. So instead, this seems like a good thing for a loop to do. So let's get rid of this, and we're going to create what's called a while loop. So the structure of a while loop is it's going to say while, and then some condition. By the way, this little hashtag here means that there's going to be a comment, so it's not going to affect the code at all. Another way you can do comments is by doing 3 quote signs and then another 3 quote signs, and then writing something in between them. So that's what I'm going to do right here. So while a certain condition is true, then we have a colon. We want to make sure to indent by at least 2 spaces, because that's how Python figures out how things are grouped together, by using these colons and then spaces. So while this condition is true, I'm going to use the hashtag comment. We're going to do something. Now, if the thing that we're doing inside of here doesn't affect the condition at all, then we'll just be looping forever, because the condition might always be true. So whatever we do, we want to make sure that the condition eventually becomes false, based on something we either do in here or somewhere else in the code, but we don't want this to end up looping forever. So what's the thing we want to do in this case? Our do something is going to be cups, and we're going to increment it by 1. Same thing as before. Increment cups by 1. And what's our condition going to be? It has to be false eventually. So what did we say? Our bowl is going to be full as soon as 6 cups have been added to it. So I can say something like, while cups is smaller than 6, we're going to do this. So what's going to happen? It's going to keep going, adding 1 cup at a time to the bowl until it reaches 6. As soon as it reaches 6, this is not going to be true anymore. And then it breaks out of this loop to right afterwards. So we have cups equals 0. Let's do a print here. And now let's do another print after this is done. And it should be at 6, because it should be full, and it should have broken out of that loop. There we go. It started out at 0 cups. We keep adding 1 cup at a time, looping over and over until we reach 6. This becomes false, and then we end up here. We break out of the loop. Another thing you can do is break out of a loop by hand. So for example, if I have a condition that's always true, the simplest would be while true. This will just loop forever. We add 1 to cups, but we can do something else called an if statement. An if checks whether something is true or not. So if we say if cups, we're going to use 2 equal signs to check if it's equal to a certain value. So I'm going to say if cups equals 6, we're going to use that colon again. And what's nice about Colab is it automatically indents. So if cups is equal to 6, then we could say something like break. And that'll actually break us out. And this will actually do the exact same thing. 0 and 6. So these are equivalent. This is just a more complicated way to write it. But if you need to break out by hand for some reason, this is how you do it. So in Python, while loops are really good for doing something for as long as a certain condition is true. But another reason we might need to loop would be in order to look at every piece of something. So for example, what if we had 10 frogs and we wanted to know the color of each frog? What would you actually need to do during each step of the code for that? You would look at the current frog that you have and say what its color is. So one thing you could do is just write the same code 10 different times. But that would take up a whole lot of unnecessary space since you're just doing the same thing with each frog, and you could use a loop instead. So to simplify things in this case, we can use what's called a for loop. So here's our for loop example. So for a for loop in Python to work, we need something for it to look through. The most common thing for this purpose would be a dictionary. A dictionary is just like a dictionary that you find on your shelf. It's going to have some kind of key, like the word in the dictionary, and then a value, which is the definition of that word. So let's try it with frogs. I'll show you how this works. So this is what a dictionary looks like. This is our first dictionary example. We have these curly braces, and then you're going to have something in quotes, and I'll just call it frog1. Then you're going to have a colon and something else in quotes. So in these quotes, I'm going to give it a color. So I'll say, this frog is green. And then if you want to add another one, all you have to do is put a comma, and then you can just keep copying and pasting this. So I'm going to take this whole thing right here and copy it. I'm going to paste it 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's get rid of this last comma, and let's give some different colors to these frogs. So this one might be blue. This one might be red. Maybe there's a few more green ones. This one might be white. This one might be spotted. This one's going to be black. Okay, so what we could do is go to each frog separately and see what its color is, but we want some more automated, easy way to do that. So we can use a for loop. So all you have to do is say something like, for frog in frogs. Now we haven't actually said what frogs is, so I'm going to create a new variable. A variable doesn't just have to be a number, it can actually be a dictionary. So I can say frogs equals this whole thing that we just made. So I could say for frog in frogs. And what's happening is it's looking at every element of frogs, and it's going to pick out the individual frog. Now I didn't have to call this frog. I could call it for Billy in frogs. For Billy in frogs. It doesn't matter. This is just whatever we're going to be calling it because we're going to reference it later. So for frog in frogs, making sure that we have this indent, we're going to say print. So we're going to print something. What are we going to print? Well, let's have a new variable. Let's call it color. Color equals, now this is how you access something inside of a dictionary, like you're looking it up. The frogs dictionary is what we're looking inside. Then you have these square braces, and then we're looking at the entry for this particular frog. So this is a little confusing, but we're looking at every frog inside of here one at a time. So first it's going to find frog 1. That's our first frog. Now it's going to look up in this dictionary the corresponding color or value for that particular frog. So what's the color for frog 1? Well, it's green. Now that's going to be assigned to color right here. And then we could print color. So that'll print the color of that frog. Now what's cool about for loops is it automatically goes through every element in here, and then as soon as we have no more elements, it'll stop. So let's try this out, see what happens. Okay, I was just getting an error and I just realized that I didn't change the name of these frogs. So now it thinks that these are all the same name. So you can't have overlapping names in the dictionary. That's like if you're looking up the word water and every element of the dictionary says water, and it's like, well, which one do you use? So I have to change these. So it has to be frog 2, frog 3, frog 4, frog 5, frog 6, frog 7, frog 8, frog 9. Okay, so frog 10. There we go. Now this should work. There we go. So we have 10 results, 10 different frogs, and you notice that these are the same colors as we had up there. So this is how you use a for loop. You loop it over and over for every element in some list or some dictionary. So for loops in Python are similar to what's called an iterator in other programming languages. These are like special machines that find every element in a list and do something with that element, and then the loop stops when you reach the end of the list. Now in this case we used a dictionary, but you could also do something called a list, which you have with square braces, and you could have maybe like numbers 0, 1, 2, 3. And now for frog and frogs, we can't do this anymore, but maybe we'll just say print I'm a frog. So now it's going to go to every element in this list, 1, 2, 3, 4. So it should happen 4 times, and it's going to print I'm a frog. There we go. We get 4 I'm a frogs. So that's an example using a list instead of a dictionary. Lists and dictionaries are the two main ways to store data built in to Python. So loops aren't anything to mess around with. They're very powerful, and they're so powerful that you can theoretically write any piece of code using just loops. So now that you understand the basics of this, try experimenting with some of these ideas. Write some recipes of your own for the computer to cook up. Maybe it'll even make something tasty. I'm Devon, and thanks for joining me with Coding Simplified. See you next time.